Chapter 3 is all about exponential and logarithmic functions. And we've touched based on those in our class last year. So we're going to, as with the previous two chapters, touch base on what we talked about the previous years and then go a step further. So exponential functions are written in the form, the most basic form, f of x equals a to the x power. So your variable is now in your exponent instead of in the terms of the equation. We have two types of exponential functions. We have one where the number being raised to the x power is a number larger than 1 that we call exponential growth. And then we have when the number being raised to the power is between 0 and 1, but not equal to 0, not equal to 1. And we call that exponential decay. Now, one of the things to note is that your a value, the number being raised to the power won't be negative. So no matter if you have growth or decay, the number being raised to that exponent won't be negative. So exponential growth, like I said, your a value is bigger than 1. And the domain of all exponential functions is negative infinity, comma infinity. The range is 0, comma infinity until we have some shifting up and down. Y-intercept is 0, comma 1, again until we have some shifting. And then our horizontal asymptote is y equals 0. And our function is increasing from left to right. So a rough sketch of this would look like this. And our asymptote would be at y equals 0. Then we go and look at exponential decay. You'll notice that we have a negative exponent. Well, we know that a negative exponent, what you can do is write that over 1 and then put that into the denominator, which is what we have right here. And that's what you were used to seeing last year. That exponential decay function was a fraction being raised to the exponent. Because notice now that the exponent went from negative to positive now that we put that a into the denominator. Now you'll notice that everything is the same except for the decreasing part. So our y-intercept is still 0, comma 1, and our horizontal asymptote is still at 0, and then our graph will decrease. It will never equal 0 though. So now let's talk about how to graph them. So we're going to kind of ignore what we did last year in algebra 2 because different teachers graph them differently, and we're going to focus on this stuff over here on the left. The very first thing we'll do is find our horizontal asymptote, which will be that b value. Now, we don't have a, h, and k like we are used to, but we still have h and k. They're just written a little bit differently. You'll see we had x minus h here, but now it's x plus c. And instead of plus k at the end, it's at the beginning. So our horizontal asymptote is y equals b. And that can be written either at the end of the function or at the beginning. And then we're going to find the y-intercept by plugging in 0 for x. And then we need one other point, and we can do it one of two ways. If we can, it's a lot easier to translate the original y-intercept 0, 1 based on the function. Now, you can only do that if you have a c value, if you are translating left and right. So can only do this if translating left or right. And you'll see in our examples a situation like that. Otherwise, we have to pick a number for x that gives us an integer y value. So we may not want to pick 1, 2, 3, or 4. We may want to look at the function and say, okay, if we say x is equal to 4, that's going to give us a nice integer that we can plot. Or if x is equal to -3, that will give us a nice integer to plot. And then the domain for all of these is neg-infinity, infinity, and we're going to list the range in interval notation. So then we're going to graph these. So we have 2 to the x plus 3 minus 1. So our horizontal asymptote, our HA, horizontal asymptote is y equals -1, the number being subtracted at the very end. So I want to draw that. Now our y-intercept. Our y-intercept, we're going to substitute in 0 for x. So we get 2 to the 0 plus 3 minus 1. Well, 2 to the 0 plus 3, that's 2 to the third minus 1. 2 to the third is 8 minus 1 is 7. So 0, 7 is our y-intercept. Now to find our other point, we could take our original y-intercept from our parent function 0, 1. We could take 0, 1. So other point, we could take 0, 1 and translate left 3 and down 1, okay? Because it's plus 3 and minus 1. So we take that point 0, 1, we go left 3, down 1, we get negative, we would get -3, 0. Okay, that's right there. Another way of doing it is looking at the original function and say, okay, what if we could get that to say 2 to the first power or 2 to the second power, some nice integer that we can easily calculate. So what if x was equal to negative 1? So f of -1 is equal to 2 to the second power minus 1, which is 3. So that gives us -1, 3. You know, when we plugged in -1 here, we get -1 plus 3. That's how I got 2 to the 2 power. So you could have done that. So we had options here. Like I said, translating is probably the easiest, but we can't always do that. So now we're going to draw our graph. Our domain is always -infinity, infinity, and our range is -1, infinity. Notice it's always parentheses because we can never reach these values. All right, now this one, we have 3 to the -x plus 2. Well, if it helps you, and it helps me, so I'm going to rewrite it this way. This is really 1 over 3 to the x power plus 2. And again, we could use either one of these depending on what we're trying to figure out. This is a decay function, and it is shifted up 2. That's what that plus 2 means. So our horizontal asymptote is going to be y equals 2 because of that plus 2. So then our y-intercept, let's substitute in 0. So f of 0 equals 3 to the 0 minus 2, or sorry, plus 2. 3 to the 0 is 1. We get 1 plus 2, which is 3. So we have 0, comma 3 as our point. Now for our other point, let's go ahead and plot that 0, comma 3. Now for our second point, if you were to take the original y-intercept, 0, comma 1, and translated that up 2, because of that plus 2, that 0, comma 1 becomes 0, comma 3, which we already have. So we can't use that again as our second point. So we got to pick a nice value of x. Now, we could pick a positive value like positive 1, positive 2, but then we're going to have a fraction, and then we're going to have to add 2 to it. What if we picked a negative number for x? What if we did x equals negative 1? So f of negative 1 would be 3 to the negative 1, because the function says negative x plus 2. Well, that's going to be 3 to the first power plus 2, which is just 5. So now we have negative 1, comma 5 as our other point. So now we have our 2 points, and we can graph. Domain, negative infinity, comma infinity, and our range is going to be positive 2, comma infinity. Okay, so now let's look at the ones down here. We have 2 to the x plus 3. And that plus 3 means that we're going to shift it up 3. So because we are not shifted left or right, we're going to run into the same issue that we ran into here, where our new y-intercept is going to be the same as our old y-intercept translated up 1. So our horizontal asymptote is y equals 3. So 1, 2, 3. And then we're going to calculate that y-intercept. So f of 0 equals 2 to the 0 plus 3. Well, 2 to the 0 is 1. So we get 1 plus 3, which is 4. So 0, comma 4 is our point. Now to get our second point, our OP, other point, we can pick again a small number. Let's just pick 1. So f of 1 equals 2 to the first power plus 3, and that's going to give us 5. Now, there are some situations and some teachers that may want you to pick a larger number, because this is going to look linear even though it is exponential with just those 2 points. So just be mindful of that. Please, you do not want to draw that. These are exponential functions and not linear functions. So your graph needs to come up like that. So we had 1, comma 5. So then our domain is negative infinity, comma infinity, and our range is 3, comma infinity. All right, then this last problem here, we have 3 to the x minus 2 minus 1. So, that's going to make us go right 2, and this minus 1 is going to make us go down 1. So our horizontal asymptote is y equals negative 1. So let's go ahead and draw that. And then our y-intercept, so f of 0, is going to be 3 to the 0 minus 2 minus 1 power. Well, that's going to be 3 to the negative second power minus 1. Well, 3 to the negative second is negative, sorry, not negative, 1 over 3 squared minus 1, which is going to be 1/9 minus 9 over 9, which is negative 8 over 9. So we're going to have 0 comma negative 8 over 9. And like our other graphs, I'm not looking for it to be perfect, but it shouldn't be at negative 1, but it should be really close. Now for this other point, again, we could take 0 comma 1. So my other point, we could take 0 comma 1 and translate that. We wrote down right 2 and down 1, arch 2, down 1, and that would be 2 comma 0. And we get that, and then our graph would look like that. All right, so this was a basic recap of exponential functions, and just kind of what they will look like, and just kind of putting that new twist in it with trying to figure out what that other point would be by substituting in convenient values. So thanks for watching. Make sure to like the video and subscribe.